Hello dear students, now today we will discuss splitting of d orbital in a octahedral complex compound. Now we have get idea about a crystal field theory, we have understood about d orbitals, what is meant by crystal field splitting, everything is studied by us in a previous lecture. Now today we will discuss in detail splitting of d orbital in a octahedral complex compound. Now octahedral complex compound आपको पता है किसको कहते हैं? Now whenever metal ion joint with a 6 ligand molecule, then whatever complex obtained it is considered as a octahedral complex compound. अब उसकी ज्योमेट्री हम इस तरह से लिख सकते हैं. In a complex compound, center will be formed by a metal. Now it is joined with a 4 ligand in a same plane. सपोज ये आपके पास वन प्लेन है, उसके सेंटर में मेटल होगा, उसके 4 कॉर्नर पर 1, 2, 3 एंड 4 लिगेंड है. अब टोटल 6 लिगेंड हो गए Ml6 टाइप ऑफ कॉम्प्लेक्स. सो एक ऊपर के साइड और एक नीचे की साइड लिगेंड अरेंज होगा. सो टोटली 6 ligand will be arranged in this way. One will be above and one will be at bottom. So this is the geometrical shape of octahedral complex compound. So in this way, in an octahedral complex compound, shape of molecule is there. Now, when ligand atom arrange around a metal, then interaction occur in between a ligand electron and unpaired electron present in a d orbital. And because of this, the energy of d orbital will change, or we can say degeneracy of d orbital will break, and it is converting in a higher energy orbital and lower energy orbital. This thing is known as a crystal field splitting. यानी degeneracy of d orbital break होती है, वो हमारे crystal field theory का base है, and this energy gap is known as a crystal field splitting. तो फर्स्ट हमें ये समझना पड़ेगा कि d ऑर्बिटल कौन कौन से टाइप के हैं. तो हमें पता है d orbitals are of totally 5 type. Which are these 5 type? You are knowing very well. Now this 5 type we have divided in 2 group, T2G group and EG group. Suppose this orbital which are lying in between the axis. Suppose this orbital are, ये मैंने x और y axis ड्रॉ कर ली है. चलो ये x और y एक्सिस के बीच की जो ऑर्बिटल हुई, then it suppose this is x orbital and this is y orbital, then it is a dxy. Similarly, I can give you this type of orbital also, x axis, y axis and z axis. Suppose lobes are present in between a y and z axis, then it is known as a dyz. And if lobes are present in between this axis, suppose मैं यहाँ पर लिख लेता हूँ x axis और ये z axis कर देता हूँ मैं. Lobes are present in between है, then it is considered as a dx. So this group, these 3 orbital which are present in between the axis, we are knowing very well. These are the T2G orbital and present in between axis. Now 2 orbital, those are present on the axis, are known as the EG orbital. तो आपको पता है EG orbital is present over the axis. So this orbital is nothing but a dx square minus y square. So this dx square minus y square, and similarly one more orbital dz square. So this orbital is present on the axis. This orbital is present on the axis. So if it is present on z axis, then it is a dz square. So d orbital are of 5 type: dxy, dyz, dxz. These are the in between the axis. उसके लोब है वो axis के बीच में है. This axis lying on the, this orbital lying on the axis, उसके लोब है वो axis के ऊपर है. अब जब मेटल के साथ लिगेंड एटम जॉइंट होते हैं, अप्रोच करते हैं, जब उसके साथ इलेक्ट्रोवैलेंट बॉन्ड बनाते हैं, then you can observe in this that ligand approach metal ion, लिगेंड अप्रोच मेटल आयन। सपोज ये मैं x y और z कोऑर्डिनेट लिख देता हूं, तो आप देख सकते हो कि भाई जो लिगेंड है वो मेटल आयन को अप्रोच कर रहा है, लेकिन इट इज ऑन द एक्सिस। तो आप देख सकते हो कि चलो ये y एक्सिस है, उस पर लिगेंड है, यहाँ पे z एक्सिस है, उस पर लिगेंड है। तो जब भी हम ऑक्टाहेड्रल कॉम्प्लेक्स लेते हैं तो यानी एक्सिस वाली ऑर्बिटल है, जो ऑर्बिटल एक्सिस पर है उसका इंटरेक्शन ज्यादा होगा। सो द इलेक्ट्रॉन प्रेजेंट इन ए d orbital means dz square and dx square minus y square यानी eg orbital having a more repulsion, having a more interactions। तो अब the degeneracy of this orbital will break। चलो इस तरह से मैंने 5d orbital लिख दिए। This all orbital having equal energy। Now in the presence of ligand, these two orbital feel more interaction or repulsion. As a result, the energy of these two orbital will increase। Now similarly, these three orbitals having a less interaction with the ligand, suppose dxy, dyz and dxz, the electron present in T2g orbital having a less interaction with a electron of ligand, therefore the average energy of this orbital will decrease। So we can write that here T2g orbital energy decreasing and Eg orbital energy is increasing। So the average energy level is given by the symbol। So whatever the average energy level we have, it is known as a Berry center। Now the difference in energy of T2g and Eg orbital is known as crystal field splitting energy। It is given by symbol delta or dq। We can write it as a 10 dq। Now this difference in energy of T2g and Eg orbital, energy of Eg orbital increase, energy of T2g orbital decrease। So this difference for octahedral complex, it is denoted by O। So you can see that energy of Eg orbital increase, energy of T2g orbital decrease. Then how much it increase or decrease, then we can write here 3/5, and this decrease will be nothing but a 2/5 as compared to 2 orbital, energy of this 3 orbital decrease. So we can write in this way also minus 0.4 delta O decrease, and here increase is 0.6 delta O। So d orbital split in a T2g and Eg, the energy of T2g orbital is decreasing, the energy of Eg orbital is increasing. Now due to this, the change occur in energy of complex compound। So whatever change occur in energy of complex compound, it is known as a CFSE। It is known as crystal field stabilizing energy। Now for any complex compound, this crystal field stabilizing energy can be calculated by using this equation। Now here you observe that 0.4 जितनी उसकी एनर्जी कम हुई, तो we can write in this way minus 0.4 n T2g plus इसकी एनर्जी इंक्रीज हुई, then we can write it plus 0.6 n Eg, 0.6 n Eg and out of bracket delta O plus mp। अब आपको क्वेश्चन होगा कि what is here N-T2G? N-T2G means what? Number of electron present in a T2G orbital, and here N-Eg means number of electron present in a Eg orbital। So here what is N? Number of electron। Okay, what is delta O? Delta O is nothing but a crystal field splitting energy। Crystal field splitting energy। So this splitting energy, crystal field splitting energy, you can calculate with help of UV spectrophotometer। So by using this UV spectrophotometer, this delta O, crystal field splitting energy, means what is the amount of energy absorbed from white light can be calculated. So the splitting energy, it will be present in a centimeter inverse and calculated by using a UV spectrophotometer. Now M and P. So P is nothing but a pairing energy. अब इलेक्ट्रॉन की अरेंजमेंट होगी अकॉर्डिंग टू अबव प्रिंसिपल्स. सो इन दिस अरेंजमेंट कितने इलेक्ट्रॉन पेयर्ड है, वन क्लॉकवाइज एंड सेकंड एंटी क्लॉकवाइज. तो कितने इलेक्ट्रॉन की पेयर है, उस पेयर के नंबर को हम बोलेंगे m. सो m इज नथिंग बट अ नंबर ऑफ इलेक्ट्रॉन पेयर and this p is pairing energy. Now if we know the splitting energy, crystal field splitting energy, the number of unpaired electron and pairing energy, और हमें पता है कि कितने number of pair है, then what is the crystal field stabilizing energy CFSE complex compound की क्या होगी वो हम calculate कर सकते हैं. So in octahedral complex compound, energy of Ag orbital will increase and energy of T2G orbital will decrease. Whatever increase occur is 3/5 delta O, or we can write in this way 0.6 delta O. जितना increase होता है उतना ही decrease होगा, and it is a 0.4 delta O. Now by using this equation one can calculate what is the crystal field stabilizing energy of complex compound for any complex. So उसको हम कैलकुलेट करने के लिए हमें डेल्टा O चाहिए, उसको हम बोलेंगे क्रिस्टल फील्ड स्प्लिटिंग एनर्जी. क्रिस्टल फील्ड स्प्लिटिंग एनर्जी कैन बी कैलकुलेटेड बाय यूजिंग ए यूवी स्पेक्ट्रोफोटोमीटर. तो अब हम नेक्स्ट लेक्चर में हाई स्पिन और लो स्पिन कॉम्प्लेक्स कंपाउंड के लिए किस तरह से CFSE कैलकुलेट कर सकते हैं वो हम समझेंगे. For today lecture we will stop it here. Today we have understood that complex compound, particularly octahedral complex compound, splitting of d orbital occur in this way. Eg energy increase, T2G energy decrease. Why? This we will discuss in this lecture. Okay, see you in next lecture.